Good morning, good afternoon, and good evening, depending on location you're joining from. Welcome to today's webinar titled Build Great Designs Faster with DFMPro for Creo Parametric. I am Prashant Chandanapurkar from Geometrics Limited, and I'll be presenter for today's webinar. Before beginning of the webinar, I would like to first talk about logistics of today's webinar. If you are attending the webinar for the first time, here are some quick instructions for you. The webinar is for 30 minutes. Your active participation is important throughout the session. I have kept everyone on mute to avoid background noises that may distract you from listening to the webinar. However, you can enter your questions and comments in the question box throughout the presentation. This is how the question box would look like, and you can put your questions and just click on the send button to send all your questions. Before we take a deep dive in today's webinar topic, I am going to introduce you to who we are and what we are, and I'm going to give a quick overview about Geometric. Geometric is a specialist in domain of engineering solutions, services, and technologies. We partner with our clients, supported by 4,800 employees working with all corners of the globe. We have strong relationship with customers and also with world-renowned CAD and PLM vendors. Geometric has strong homegrown patented technologies and products that help our customer to do things better and faster. DFMPro is one of such product from Geometric's family. We begin today's webinar by asking the question, what makes a design great? Now, back in 1980s, it was Sony's Walkman that had a revolutionary idea that you can carry your music with you as you go anywhere. It was lightweight, easy to operate, and it can easily fit in your pocket. We see further success even in today's world with products like Apple's iPhone, which is one of the successful products in recent times. Now, when we look at various aspects of design, we can break them into different areas. If you look at some of these areas, like for example, function, it should do whatever it says it does. If it's a refrigerator, it should provide cooling. It should be available at the right cost. It could be initial cost, or it could be total life cycle cost of the product, depending on the market you serve in. Quality is nothing but the fitness for the purpose. Generally, it is based on a perception, but it should be also endorsed by the customer. It should be definitely efficient. It should be better than the existing method, and it should save the time. The next aspect is also about safety and things like reliability. This way, we can build in various parameters to make a product successful. But at the end of it, a successful product is nothing which meets or exceeds the customer requirements. And in the next slide, we are going to see that these requirements of the designs are further converted into design requirements. You can add further parameters to the definition, but what it means is that you must meet this customer expectation. There are nothing but prerequisites for any design to start. Generally, these requirements are captured by sales and marketing and provided as input to design. A designer's role is to transform these customers' requirements into functional product. But a designer has to spend a lot of time in looking at various aspects of the design and validating these designs manually. Now, if we look at some of the examples, for example, the picture what you see on your screen, in this assembly, the question could be around quality. And for this particular part, the question is if there is a uniform wall thickness maintained for this part which needs to be casted. Similarly, is it meeting the environmental requirement? Can this contact area lead to corrosion because of incompatible materials? It could be a question around reliability. A designer has to think about reliability. Is the thread engagement sufficient for the joint? Will it be reliable on the field? Things like manufacturing. For example, can this fillet radius be achieved throughout the casting process? Is the manufacturing cost within the target? Because generally this is something which designer has been given from the sales and marketing side, that okay, for this product, this is the overall target cost you need to fit in to make sure that it meets the end customer's requirement or the target cost. Similarly, around service, here you can see there is a fastener, and the question is this fastener accessible for serviceability? The person who's going to be there on the field, will he or she will be able to service it easily? Whether is it accessible? Similarly, question around assembly, is this hole aligned properly? Or even on the side of manufacturing, is the correct draft angle maintained or applied on this part for ease of manufacturing? Similarly, there is a question around, is adequate clearance maintained between these two parts to meet the functional requirement? So a designer in today's world has to look at all these things together, which makes the life difficult for designer. There is a challenge in the design that typically consumes a lot of designers' time, as there are a lot of design iterations happen through the process. Now, typically these issues are difficult to detect manually and they take long time to correct. More than often, engineers spend around 30 to 40% of their time addressing these challenges. We say that these design changes or any changes in this design come at various stages. It could come right when the product definition is frozen, the designer is working, and then there is a change. It could come during the manufacturing time, or it could come at the time of final assembly. Now, generally, you go through a various process of prototyping, but day by day now the world is shifting towards digitization, and more customers are now going for sort of a virtual prototyping. So it is not possible for certain processes to actually create a prototype all the time and try to test on it. So the biggest change which is happening in the industry is that more and more virtual validation of the design is happening. So that creates a lot of challenges for designers. The timeline which is required for building a new product is shrinking, and that puts designer in a tight spot where you have a pressure about everything. You have pressure about cost, you have pressure about time, you have pressure about quality, and all these aspects. So how do a designer can address all these issues? Typically, if you see some of these challenges that have been discussed on this slide, these could be in various areas. For example, if you see on the left hand side on the top, it's an example of a misaligned hole. Now, typically a misaligned hole will cause problem during the assembly process. It would lead to a lot of rework in design, or it could be a rework in downstream manufacturing. While manufacturing or a machining of a part, if a sharp internal corner is applied to a part with a conventional process, it is not possible to create this sharp corner with a milling tool, and maybe something like a EDM or wire cut process is required. Now that is something which is going to impact the machining cost. Similarly, the design rework would lead to similar problems in case of an injection molding. Like for example, you see two faces here of this part and this part, which are very near each other. This will reduce the tooling life significantly, typically known as problem of thin steel condition, where the tool is really thin and it will wear out during the ejection process, and this takes long time to detect manually. Now, what happens to address these issues? Generally, an organization will have design for manufacturing or design for assembly or similar design guidelines which are typically followed across the industry. Let's take a case study about one of such design guidelines, wherein the guideline states that a chamfer hole should have edges. So you can see that there is a chamfer hole, and a common guideline for ease of assembly is that you have to provide chamfer holes to make sure that locating of the fastener or locating of the pin is much easier. On the right bottom side, you see one example here, which is an example of design for assembly, a study which was done back in Germany. What it states that you have a part here which is having a sharp edge like that, and here also hole where the holes are not chamfered. Now if you put a radius or if you put a chamfer on one of the parts like pin, the time for assembly goes down to 86%. If you provide sort of a chamfer on a hole, it goes down to 70% time saving, and if you provide chamfer on the both parts, there is a significant time saving in this, where the time reduces to almost 57%. So you can see that this kind of guidelines are typically available in industry. Currently, the manual way of validating designs for such guidelines consumes significant effort and time for organization. Most often, we see that because of the late stage design changes or last stage engineering change request, it impacts the product launch deadlines for organizations. Some of the extreme examples what we see in automotive industry, where maybe because of some design issues or some of these guidelines are not adhered to, they go to field, and that's why we see a lot of automotive recalls which typically happen. Now these are some of the extreme examples wherein these kind of guidelines or best practices are not followed, and they lead to these problems. Now that's where DFMPro comes very handy. So if you look at the workflow here, a designer is working on a 3D model. So here in this case, if a designer is working on a Creo parametric platform, it will go and sit into that CAD system. DFMPro provides something what we call as global best practices followed across industry. It helps to capture even downstream requirements which are either coming from your in-house best practices, coming from sourcing, they're coming from manufacturing, or even from service. These best practices are captured here and stored in geometric DFMPro solution. Now DFMPro addresses these challenges by bringing in automation in the process. So it helps a designer to design faster and better, driven by knowledge and collaboration. Now the way it works is that, as I mentioned, it covers some of the global best practices followed across industry, and those are divided into various processes. So there are processes like injection molding, sheet metal, casting, assembly, machining. Along with these conventional processes, there are also even some of the modern processes, like for example, additive manufacturing, or commonly also known as 3D printing. There are also guidelines which are required for these advanced processes, and that's where DFMPro comes as a assistant for a design engineer to validate design right when they are happening. Now with this, I'm going to quickly show few examples and demonstrate how DFMPro will help a design engineer to quickly validate and make sure that these guidelines are followed and the design can be created right the first time. With this, I'll now shift to a demo. Once DFMPro is installed, it will be installed as one of the menu. A designer has to click on Start DFMPro button, and you can see that there are only two inputs which are required from a designer. One is something called as a rule file, which is nothing but predefined list of checks. Now these are, again, as I mentioned, some of the global best practices followed across the organization, which could be further configured as per individual organization's requirement, or even by department, or even by geography. And I'll come back to this during the second part of my demonstration. The second input required or from a designer is to pick a process. So here you can see various processes like milling, turning, sheet metal. Since I'm going to validate it for assembly, a designer has to just click on assembly and just hit the run button. So with a click of a button, as I mentioned, Geometric has patented technology wherein it will be able to automatically recognize various features, like for example, features like holes. If it's a plastic, then features like bosses, or various features on the design that are required to be validated. And you can see the progress here, various checks the system is doing on this assembly. One of the interesting point here is that it's not necessary to be a native CAD design. Even if you are running it on a step file or IGS file, you will be still able to run these checks with DFMPro. A designer is then presented with results. On the right hand side, you see the red crosses. Those are typically the violations or examples. The components which are not meeting the standard guidelines or those criteria. The green crosses are the one where the rules has passed, and the blue ones are the ones which are not applicable. For example, if I sort it by different rules categories, I can click on the root node and hit the first instance, and you can see that now it's showing one of the instance in which there is a hole which is misaligned by 2.34 mm. Now this is typically a problem where because of the misalignment, this could create problems during the final assembly process, and this needs to be corrected. So as soon as this kind of a issue is identified, a designer can take a corrective action because you are already in the CAD environment, and this problem can be fixed right when the design is happening. If I'm a designer, I would like to know more about this kind of a checks or guidelines. I can just right click. There is a contextual help which is available, and if I click, it will provide me further information about that particular rule or a check, and it shows what the whole alignment rule is all about, what kind of a parameters are required, and what feedback. So here there are three types of checks which are happening. It is checking for the actual hole alignment. It's checking for the radial hole alignment. It can identify different types of a hole. For example, the holes which are misaligned, in case if there are holes which are blocked holes, or even if there are holes which are unused holes. So this kind of a checks can be very easily performed. Similarly, there are very interesting checks. For example, here, in case of an interference checks, what it does is that if you have a very big assembly, it will hide the rest of the components, and it will show only those components which are interfering or clashing or clashing in the design. So you can see that as soon as I click, it only highlights those two components, and the rest of the components are hidden. Similarly, there are certain interesting checks, like for example, here is one check which is about fastener accessibility. If I turn the options, it will now show all the components, and you can see here it is highlighting this assembly where there is a fastener and there is another fastener located on the other side. And what it means is that accessing this fastener could impede with another fastener, and this could create problem either during installation or during the service. Similarly, if I click another instance, it is highlighting this fastener. I can zoom, and if I take a top view, you can see that if I'm going to fit any tool here, it's going to go and hit this surface on the other part. So this could create potential issues which are related with accessibility of the fastener. Similarly, you could see other instances which are related with fastener clearance. So here it's highlighting one of the fasteners. Again, for ease of visualization, I can go and show only failed components. And if I again go and click on the instance, it is showing that there is a fastener here, and it is not meeting the standard criteria for clearance. A designer will get a quick feedback about what kind of a fastener it is and what criteria it is not meeting. So here you can see that there is a fastener. There is actual clearance requirement which is 0.25 mm, and the required value for clearance is 0.3 mm. So this way you can get a very quick feedback about various issues which are related with clearance, checks which are related with interference, accessibility, serviceability, and so on. So this is about the assembly module. You can also do checks which are on the part, like for example, I'm now taking an example of a sheet metal part. The workflow for a designer remains the same. I click on DFMPro, start DFMPro, and just select the process here. You can see that there are various processes listed like milling, sheet metal, tubing process, injection molding, die casting. I'm going to take sheet metal as an example and hit the run button. Now, similar to what we have seen in assembly, this analysis is done on a part wherein the system will automatically identify various features on sheet metal. For example, different type of bends, different type of holes, and based on analysis, it will give a feedback. Now it's giving a feedback that, okay, here in this case, there are 3 criteria which are not meeting. One of the example here is that the hole is very near to this part. And again, as a designer, it gives me a feedback about a number. Like for example, here the distance to thickness ratio, wherein there is a hole which is near to this bend. This ratio is currently 1.516 and the recommended value is 2. So it is also giving a solution to a designer that this hole should be at least 2.4 mm away from this bend. Now what it's doing is that it's automatically identifying this hole and the bend, and it's applying that particular rule or the guideline in practice. So this way, as a designer, then I can take a quick corrective action, move this hole and make sure that this meets the standards or criteria for manufacturability. Similarly, you can see that it's highlighting another feature here, and it's saying that the whole hem opening to the thickness ratio is currently actual value is 0.16, while the recommended value is 0.25 mm. So use the hem opening value to be 0.3. I can again right click and seek further information about how I can design this hem better to suit the manufacturability criteria or the standard guidelines. You can see here a detailed help which is available, which provides more information on various checks like tolerancing, a process like drilling, milling, turning, even in sheet metal, different type of bends, checks around features like burying holes, counter bore holes, different type of holes like dowels, features which are typically used for manufacturing like half shear. Even there are some checks which are around safety. For example, here is a check which is around knife edge. So this check is about that you should not have very sharp edges on sheet metal part or knife feature, because it's very difficult to handle and that could lead to injury to the person who's working on the field. Similarly, there are checks around flange heights. There are checks which are around features like width of a cutout, slots, and so on. So you can see that there are various processes like injection molding process, where it identifies features like checks like drafts, different type of features like ribs, features around bosses, and so on. So all these standard checks are already built into the system. What it also provides is an ability to do configuration. So as I mentioned, you can go to edit button and click on the configuration. So for example, if I am doing a design of an injection molding part, and if there is a feature which is related with, let's say for example, there is a check called uniform wall thickness. Uniform wall thickness is a check which states that you should have a uniformity in wall thickness for plastic parts. This is also available for this is also similar check is required for casting parts. The requirement is that unless you maintain the uniformity of wall thickness, you are going to have a lot of issues with the flows, and this could create problems during manufacturing. You will have quality issues, you will have issues which are related to porosity and so on. So basically for checks like uniform wall thickness, you have a complete configuration available. You can provide absolute values. This configuration is only required for the first time of operation, or typically when the solution gets deployed in the organization. You can select on, for example, things like recommended thickness for materials. You can configure your own database. You can add different type of a material, like for example here different type of steel grades, or if it's a plastics, then I can select a different type of plastics like ABS, epoxy, and so on. So it has a complete database wherein it will automatically read. If you have already specified the material in the Creo file or your CAD file, it will automatically read, and based on that, that particular check will be done. So this way it provides a very quick feedback to a designer on how the design could be further improved, and to make sure that the designer doesn't do rework. Now, as I mentioned, typically a designer spends almost around 30 to 40% of the time. All that can be very quickly cut down, and basically you can create a design right the first time. I hope with this short demonstration you have got an idea about how DFMPro helps designers to avoid late stage design changes and build designs quickly right the first time. Now with this, we are open to question and answer session. If you have any questions, please put down in the questions window, and I'll try to take and answer as much as possible. So here is the first question. Does DFMPro supports family table in Creo? Yes. If you are going to do any assembly analysis, it does supports the family table, and you can use it for validation for assemblies as well. The second question is that at what stage of design DFMPro should be used? So let me say that DFMPro is a design assistant. It's more like your spelling checker, right? I mean, many times when we use typical applications which are meant for for writing or writing emails, it highlights the spelling mistakes or the mistakes which are made in grammar. So similar way, what DFMPro does is that it's giving a feedback to a designer as soon as you run, and it gives you a quick idea about how that design can be further improved. So the way our customers currently use it, that they use throughout the design process, like as soon as, let's say, you complete 10%, 20% of your design, you can do a quick check. Since many times, designers are also evaluating various options. So for example, if I have a particular kind of a design, should I make it out of plastic or should I make it die cast? So here you can also take various options, run it, and also evaluate various design options. So I should say that we have seen designers using it throughout the life cycle of the way you are designing the product. And it's doing various checks, like checks around wall thickness, checks for features like draft angles, mold wall thickness. And once you have this, you can click on generate report and say OK. Now you have three different types of reports here. One is what we call typically an HTML report, where it provides a quick overview. This is especially useful if you are dealing with manufacturing, or if you are dealing with supply chain where there is no CAD system available. You can share your feedback and basically invite and basically collaborate and basically share this report. For your individual tracking, you can use spreadsheet or Excel sheet kind of a report, wherein you can put your own progress, any instances, any violations you see, what is the action, corrective action you have taken, what is the status, and so on. And there is also a third report which is optional, what we call typically a e-drawings report. With this you can also collaborate. So for example, if you click on one of the instances, you can see that it is highlighting a boss, and what it is showing that the minimum radius at the base of the boss is 0.25 mm and the nominal wall thickness is 3 mm. The actual value is 0.83, and hence the recommended value is 0.75 mm. So currently here the radius is 0.25, you need to make it 0.75. You can highlight this and say that make radius 0.75, and this way you can put your comments and share it with manufacturing or even with your suppliers without even sharing your original CAD file. I hope I've been able to give answer to this question. Okay. So next question is, what other CAD platforms DFMPro is supported? So yeah, I have demonstrated it with the Creo platform, but it's supported on the all major CAD systems what we use. Like for example, SolidWorks is there, or if it's NX is there, you have all the systems on which DFMPro is supported. We are almost on time, and I hope you enjoyed this webinar. For now we are closing the sessions, but you will also get a short link. You can also visit website www.dfmpro.com, wherein you can get further information, videos. You can also call us or drop an email to info@dfmpro.com. We will also be sending a link to recording of this webinar in few days. Meanwhile, if you have any questions, please feel free to write to this email ID info@dfmpro.com, and we would be happy to answer your questions. Thanks again for your time, and have a good day.